The microwave devices used in NRAO's radio telescopes are intricate pieces of technology that must be designed, machined, and finished with precision and care in order to function properly on telescopes. In this video, we hear from the team at NRAO's Central Development Laboratory that performs much of this exacting work. It all begins with the microwave engineers, who use high-performance simulation tools with advanced computational algorithms to model and analyze the behavior of microwave circuits. These virtual devices are then turned over to CDL's mechanical design, precision machining, and finishing team, whose members turn the virtual devices into real functioning pieces of hardware. For many millimeter wave devices, the machinist must manufacture devices to an accuracy of just a few microns, just a few millionths of a meter. For the final step, the devices are plated with a thin layer of gold to prevent oxidation, which could, in time, degrade the performance of the devices.
My name is Greg Morris. I'm a senior mechanical engineer here at the Central Development Lab. My responsibilities are to oversee and manage the machine shop, the plating lab, and also mechanical design. I've worked on just about every major project in the last 38 years here at the NRAO. I worked on the very long baseline array project. I worked on the Neptune Voyager project. I've worked on the Green Bank Telescope project. I worked years ago in industry, and of course industry, a lot of times you're focused on manufacturing things, and of course they're looking to make money. And it's a big focus on what they can sell and how much money they can make. But here it's a research and development like project, and it's also different things every day. We always have a different, unique problem that we have to solve, especially here in the machine shop. You know, we have higher frequencies that we're trying to achieve, and that means new ways of machining things, new techniques, better machinery, and I think we're accomplishing that here in the CDL machine shop.
I like the environment here, the work environment. I like the people I work with here, both the guys in the shop and the engineers that I interact with. I feel like everyone has a good attitude about their work. We all work together, and that I get to own the parts that I make, get to own the process from start to finish, and decide how the parts are going to be made, and make them and inspect them and deliver them to the final customer.
I work on various projects, and one of the main projects currently at the CDL is the ALMA Band 6 version 2 receiver. I'm also doing some plating for the Green Bank Observatory. But honestly, the R&D environment's a lot different than my previous more manufacturing related environments. R&D allows you a little bit more flexibility in how you get to the end goal. There isn't a strict process that necessarily needs to be followed.
I mean, there's a lot of things I like about working here. I mean, there are a lot of things that attracted me to this place. I really enjoy that aspect where you don't see the same thing twice. If you do, it's a little bit different. Honestly, I just enjoy coming here every day. I have a great facility, a lot of great machines. There's a lot of opportunity for just growth in my fields. Most machine shops tend to be, high volume manufacturing. I like that here. I get to see something different every day, and it keeps it challenging and interesting, and honestly just a little more exciting.
Okay, I'm going to show you some of the parts that we machined here in the CDL machine shop. First of all, I'm going to show you one of the most complicated parts that we've ever machined in the past, and this was a 1.5 terahertz mixer horn combination. Now this is one of our more recent projects that we're actually just finished up. This is a Band 6 version 2 OMT. Very high precision part. Every feature that's internal to this component, this part, has to be within plus or minus 5 microns.
So this is one of the typical designs we might do for the RF and electrical engineers. If we look inside here, we can see the waveguide, and that design will come from the electrical engineers, and then I take that and I'll integrate that into this this mechanical package,
What we initially do is take a three-dimensional model or print, import that into our computer-aided manufacturing software, which for us is Mastercam, and then we go about adding tool paths and kind of strategizing how we're going to cut it. When I complete that, I can do a simulation of this, and I can kind of see what the part's going to do inside the machine, and then kind of see what the finished product may look like.
So I'm inspecting an RF mix block for the ALMA Band 6 version 2. Looking at it under the microscope. The little slots that we see here are just a little over 100 microns wide. So that is just a little bit wider than a human hair. We're also looking at surface finish. You can see in the bottom of the slot there's a lot of little marks. So we have to, that is from the cutting tool scratching the surface, we have to zoom in on that and take measurements on the depth to make sure that those scratches are within our acceptable tolerance.